All right, so last time we were talking about compounded pulley systems, right? And we mentioned that we can use a compound pulley system to be able to amplify the load, right? And so basically, if I have a line, right, and I would like to tension it, basically what I could do is I'm gonna basically attach a pulley, right, at the end of the line, right? And if I basically would like to make a tension T here, obviously it will be like a single pulley, but if I want to basically increase the tension in the line, basically I'm gonna have to make my arrangement into a compounded pulley system. And we said that the tension across the pulley will always be the same. So if I'm here, then this tension here will be what? T is gonna be equal to mg, right?
Okay.
So what I'll do is basically, so the line is gonna wrap and then it's gonna come here, right? So if I do this arrangement, then this T heat is gonna be equal to mg here because this guy is gonna be equal to this guy. So this guy is gonna be equal to mg, and then here I'm gonna have 2T. So by doing this arrangement, I can double the load in the tension on the cable, and then this is referred to as a compound pulley system. Okay, so let us look into what our slides basically entail. So this is what we have here, and this is also a compounded pulley system. So my question to you right now. Okay, so so in this example, basically, we also have a compounded pulley system. And if the tension at A is T, can someone tell me what is the tension, for example, that I am actually applying onto this object? If I'm basically pulling by a tension T on here, by how much basically am I lifting this object? I'm sorry?
T/4?
Well, if this guy is T, right? What is the tension in this part of it? So let me actually annotate this, right? So what is the tension in this cable, in this one?
هوني مش لازم تكون T كمان also دكتور.
Exactly, T. Why? Because the tensions across the pulley are going to be equal, right? How about the tension in this portion?
يعني 4T بتطلع.
Also T يعني 4T بيطلع.
Exactly. So basically what I'm doing here is I'm doing a virtual cut. Why 40? So one T, another T, and then this guy is another T right here, and then I have another T here, right? So basically, if I'm actually looking into this, I'm lifting this object, right? So basically I'm lifting here with I have one T, right? And then I have another T, and then here I have basically T2. So basically I'm lifting this object, well, let me draw it. So basically I'm lifting this object with 40, right? So my mechanical advantage right now basically has been amplified by 40. So the easiest way for you to actually visualize or observe by how much basically you are amplifying the load is basically by making a virtual cut in your pulley, and then you can basically count these. All right, so today we're going to look into another approach for actually doing this if you don't want to cut that and then visualize it. All right. Okay, so what we're going to be using is we're going to be using basically the absolute length of the cord. So if I have a cord like this, right, what I can do is basically, I know that the cord length is not going to change, right? And I can specify the distance. So let's say I have this system that I'm trying to analyze. I know the length of the cord here is going to be equal to SA. SA is being measured from this datum downward, and SP is being measured from this datum downward, right? So in this case, the length of the cable is going to be equal to how much? SA plus SB, right? Plus I have a fixed length on the pulley, which is not changing, right? No matter how much A slide or how much B slide, right? You know, this angle is going to be whatever angle it is here, right? In this case, maybe it's 90 degrees, for example, or whatever. So some angle theta, right, times the radius, right? So this is the length of the cord, but this theta here is basically constant, right? It represents basically the angle that I have shown on my pulley. So this is the length of the cord. If I have the velocity of A, can I find the velocity of V based on this equation? Can someone tell me? How can I get that?
We have everything except of SB يعني.
Yeah, let's say I gave you the position of, let's say I gave you SA as a function of time. Let's say I gave you this. Can you find velocity of B? Let's say
هلا إذا عملنا
دلتا S
الديريفاتيف
دلتا
تبع
T.
SA بنطلع VA، الديريفاتيف تبع SB بنطلع VB، وبصير معنا الإيكويشن in terms of
بس ما
VA VB.
هن موصولين يعني it's derivative تبع ST بس SA of T.
مظبوط. Okay, so I know VA مظبوط is going to be equal to SA prime. Okay, right? And if VA is positive, it means what? It means that block A is what? Is approaching C, or is it going away from C?
Going away.
Exactly, it's going away. Why? Because the way I'm measuring SA is I'm measuring it from this data. So, you know, SA prime is DSA over DT. We know DT is always positive. So if meaning basically DSA would be increasing, right? So VA is equal to SA prime, and VA is positive. It means that the distance SA is increasing. Okay? And likewise, basically, VB is equal to SB prime, right? But how can I relate these two, basically? How can, okay, let's say I actually have this. Let's say I have this. Can I
Minus
calculate this?
VA. VB is equal to minus VA.
VB is equal to bravo, but how can you get that? How can we obtain this from this equation?
Doctor, I told you بنعمل
L is a constant.
You want
L
to
constant فبتصير zero.
bravo, exactly. So this is what I want to know. You want to differentiate all this equation, مظبوط? So if I differentiate L, is the length of the cable changing? No, right? So dl dt, I can differentiate that, right? So dl dt is going to be equal to dsa over dt plus dsb over dt plus d theta r over dt. Well, we know the length of the cable is not changing, so this guy's going to be 0, is going to be equal to VA plus VB. Is angle theta here changing? No, right? Because
No, so it's zero.
it's always fixed, but sometimes it could be like, you know, the actual thing could be like kind of coming, right? It could be like changing angle, then you'd have to incorporate that. But in this case, the actual engagement along the pulley is not changing, so this guy is going to be 0. So there you have it. So now VB is going to be equal to minus VA. How can I further interpret this? So if VA is positive, what happens to VB? It's negative. How can I physically interpret that?
كل ما نبعد وحدة الثانية بتقرب.
Exactly, right? So if VA is positive, then VB is negative. Why? So VB is negative, meaning that the distance, the rate of change of distance as B is decreasing, okay? So this is basically how we can also analyze pulley systems. All right, let's actually try to apply what we just did. Let's apply it into this, okay? And now I need your help. I know I have some really smart guys in this class, so maybe you can help me out with this. So I want to try to draw the references here, and then I want to be able to set up my datums. So I'm going to draw this. So this is a top pulley, right? And at the bottom of the top pulley, basically, I have a smaller pulley. Okay, and what I have here is basically I'm going to go down and then I have a pulley here. Okay, so I'm going to go up, right? And then this guy is connected where? It's connected here, right? Okay, and then basically I have this block here, B. Okay, so this is point A. And if I'm moving VA or point A, I'm moving it with the velocity VA. Maybe someone can help me out to find the velocity at B. Can someone quickly take a guess and then tell me what is the ratio of velocity of B over VA, or how VB is equal to, how is VB related to VA? Is it going to be more or is it going to be less?
It's gonna be faster.
Over 2?
3 times more.
لا,
So
over 2. Slower by 2 times.
Slower, okay, someone is saying slower by 2 times. Someone is saying faster by 3 times, you're saying?
Yes.
Okay, let's just try to analyze it. So if the tension here, let's look first into the tensions, مظبوط. Usually, if the tension increases, then what happens to the velocity?
Increase.
No, if you are increasing the tension, it means that you have to pay for it, right? And when you are amplifying the force, you have to pay for it somehow, right? You pay for it by reducing the velocity, right? If you have a gearbox, right? A gearbox, you know what the gearbox is, right? So if the gearbox is 1 to 10, right? It means like, you know, if you are putting some torque inside the gearbox, let's say you are putting 1 Newton meter, what happens on the output of the gearbox? If the gear ratio is 10, then your output torque is going to be 10 Newton meter. You guys agree? Right?
Yeah.
But
Yes,
what,
yes.
yeah, but what is the cost for it? Like, you know, how do you pay for increasing the torque from 1 to 10? You reduce the velocity by 10, right? That is how the power is conserved, right? Or the work is conserved for, you know what I mean? So here, basically, if my tension here is T, what is the tension that I'm applying on this block, basically? If I'm making a cut here, it's going to be 3T, right?
Yes.
Okay.
Yes.
So then, so if I'm amplifying the tension that I'm putting here by 3 times, it means that my velocity should be reduced by 3 times, right? Because the power would have to be the same. I'll actually write that equation in a second, but let's first begin by analyzing this by looking at the overall length of the rope. So the overall length of the rope around this, right, is not changing. It's constant. But how can I define the length of the rope based on frames and datums, right? So I want to be able to establish the length of the rope. Okay, so I suggest maybe we can use this guy as our datum. Okay, so this distance from here to here is going to be SA, right? So if this point increases, basically, then if VA is positive, it means that SA is positive. So let's actually try to write L is going to be equal to SA. Can someone help me out now? So I need to actually get this length here, right? And let me actually, I'm going to actually call this point here D, and let me actually call this point here to be C. Okay. Okay, so L is going to be equal to SA plus this portion of the cable here. So this guy is going to be, I can neglect that. Why? Because when I differentiate L, this guy is going to give me 0. So I don't need to incorporate that. So maybe I can go all the way down and then incorporate this length here. So it might be a good idea to actually get this guy, right? So this guy is going to be what? Let's call it SD.
SD.
SD, exactly. Right? So the length of the cable is going to be equal to SA plus what? Plus SD. Mazboot. So now basically we have covered this portion, this portion. Now we actually have 2 more, right? How can I write these two, this and that?
2SC.
So I have
SD minus SC.
Bravo, exactly. SD minus SC. So I need to actually call this out, and then I'm going to reference this point as SC, and then notice all of them are using the same data, right? So the length of this cable is going to be equal to SD minus SC. So I'm going to, so plus SD plus 2 times SD minus SC. Plus, obviously, I still have, you know, these semicircles, etc. When you differentiate these, they are going to be 0. So now how do I go from here? I'm trying to, and by the way, the velocity of B is going to be equal to what? So how can I get the velocity of B from these?
دكتور سؤال صغير.
Yes.
الريفرنس كل وقت بناخده من الديتم.
Yes, the reference must be.
مش هيك ما اخذنا هون انه الSC اللي على الشمال هي مش هيك اخذناها we took it as SD minus SC because we took it from the origin فوق.
Yes, exactly. So I'm trying to express this length using this data.
Okay.
Okay. All right. So now, how can I? Now what? What should I write now? You might want to differentiate. So if I differentiate that, I'm going to get 0. Right? Derivative of SA is going to be equal to what? VA, right? Okay. Derivative of SD is going to be equal to what?
دكتور بس
minus.
سؤال بالبي اللينث تبع الكورد الموصولة عليه بي ليه ما أخذناه؟
Length of the chord, okay. Well, is it part of the actual chord? Is this chord part of the length of the chord that is not changing? No, right? So basically, I'm simply counting the length of the cable that is lapping around the pullings, right? This length here is not part of my actual length, right? Okay, if you look on the figure here, basically, right? So it basically simply stops here. Okay, well, let's kind of go into more detail here, and then we can see why we're actually not incorporating this length, why we're not incorporating this length into the actual cable. Okay, so if I differentiate this guy, what do I get? If I differentiate SD, what do I get? What is the derivative of SD?
VD, I guess.
VD, exactly, plus 2. Okay, I have VD. What is the time derivative of SC?
مش zero.
0. Why? Why is it 0?
Because it's معلقة بالفوقة بالبولي الفوق.
ايه معلق لانه ما كيبل عم يتحرك.
Exactly, it's not changing, so it's 0, right? Okay, so I'm gonna end up with 0 is equal to what? VA. I have VD and then 2 VD, so it's gonna be 3 VD, right? There you go. So now I can actually find the velocity of D if I have the velocity of A. So what is the velocity of D if I have the velocity of A? It's gonna be minus VA over 3, right? Can someone tell me how can I find now the velocity of B?
Velocity of D. It's the same as D.
Why is the velocity of V equal to the velocity of D?
Because D
it's
is
attached to it.
bringing it upwards.
It's attached to it. Okay? And if you are attached to your car, if you are sitting in your car, you have the same velocity as your car, right? Okay, and this velocity here is linear. If this object is like rotating, etc., then it may have more velocity. But this whole thing is basically translating linearly, right? So whatever the velocity of B, right? So if I'm doing this, like let's say this finger is basically B and then that finger is D, right? So if this guy is going up and down, they have the same velocities, okay? Right? They are related by a constant, and if you differentiate that constant, it's going to be basically fixed, right? So the velocity of B is equal to what? The velocity of D, okay? Which is equal to minus VA over 3. So when you are finding the velocity of an object that is connected to a pulley, all you have to do is basically find the velocity of the pulley that is basically connected to the object. And basically you see now the mechanical advantage here is 3 basically, right? So the same mechanical advantage that you also have before, it is basically here, right? So here we're amplifying the force by 3. Therefore, we have to reduce the velocity by 3. Okay, guys, any questions on how we're doing this?
بس دكتور عندي question أنا.
Yeah, sure, absolutely, of course.
Fixed.
Yeah, I think I'm sorry, you're breaking up.
البولي at point D fixed ولا it's moving?
This guy is up. Yeah, it's moving. Of course, it's moving. It's only connected by wires, right? This pulley is not moving because the center of the pulley is connected, right?
يعني it's moving up and down, صح؟
Yeah.
مش إنه.
Yes.
ماشي.
And if you still are not convinced why VB is equal to VD, I can also actually get a reference frame, right? I can also define this distance, right? And I can call this SB, okay? And then I can say like SB is equal to SD plus هذا length, okay? Up to this point. Let's call this L0, مظبوط. So SB is equal to SD plus L0, right? And then if you differentiate that, you're going to get VB is equal to VD plus DL0 over dt, but this length is not changing, so it's 0. Okay, guys, all good? Okay.
Can you hear me?
Yeah, go ahead.
Yes, I'm asking why the SC is 0 in the equation. O equal VA plus VD.
Okay, why Vsc is 0, right?
SC, yes. Yes.
Okay, SC is not 0, but the derivative of SC is 0 because this length here, this cable is not changing with time, right? This cable is not like wound around any pulley. Okay, this cable is basically from the center of the pulley to the center of another pulley.
Okay, thank you.
Okay, so that length is not changing. And okay, guys, this is very good here. Let us actually look into this problem. Okay, example 17. We have the roller at A is moving with a velocity of 4 meters per second. So I have the distance XA is increasing. And it has an acceleration of 2 meters per second square. Okay, let's do it here on a new paper.
بس example 16 حل يعني حليناه.
Yeah, we're done.
بس بلا numbers يعني بس بنحط محل VA 5.
Yeah, VA over 3.
Okay.
Or minus VA over 3. Example 17, basically we have the roller at A is moving with a velocity VA is equal to 4 meters per second. And then we have the acceleration of A is equal to how much? 2 meters per second square when XA is equal to how much? XA is equal to 3 meters. We would like to find the velocity and acceleration of block B at this instant. So we need to find velocity of B, and then we also would like to find the acceleration of B. Okay, can someone help me out to solve this problem completely? How can I set this problem, guys? Okay, so this is what we have. We have this guy.
We first need to get
Here.
Vx
Here
and Vy,
and
Yx and
basically,
Ay.
right? And we know this distance here is 4. And then I know this guy is equal to XA. That's good. I'm trying to find this velocity right here.
We get Vx, Vy, and Ax, Ay.
Okay, you want to get AX, AY?
Or Vx, Vy to get the vertical. لأنه it's only moving vertical.
معك بالX direction ما في داعي ل VY يطلع 0.
Exactly. Point A has no acceleration in Y direction, right? This is point A. Okay, essentially what I'm trying to do. So I know, okay, so this is this cable that I'm interested in, right? So this is the length of the cable. So it's like this, right? And then it comes down. Was good? This is the length of the cable. So maybe we can try and apply a similar approach. You guys agree or no? Okay, and then remember this guy is a right triangle. Okay.
بحط الX equal ل 3 بيطلع معي الكيبل من البوينت A حتى الأول بولي هي بتطلع 5 Pythagoras theorem.
Okay. So that is one way I can do it. Do we actually have the overall length of the cable, or it doesn't matter? It probably doesn't matter, right? Because anyway.
Same velocity and acceleration?
Yeah, exactly. So each point on the cable actually have the same velocity and acceleration, right? So if I said that, okay, maybe we can try to set up a Pythagorean here, right? So let's actually call that distance from here to here, okay, is actually S. How about that? Okay, then that distance here is going to be equal to what? The length of the cable, L0 minus S. You guys agree? Okay, if L0 is the overall length of the cable, if that distance here is S, then that distance here is going to be what? L0 minus S. Shake it? Okay, so what I need to do is I need to actually find S prime. If I find S prime, then the velocity of B will actually be equal to minus S prime, basically, which is the derivative of this guy. But let's actually see here if I can actually find S prime based on this. I think if you think into it, I think probably one of the best ways would be is to actually set up Pythagorean over here. So I can say that S squared is equal to what? XA square ما هيك plus 4 square. You guys agree?
Yes, doctor.
This is always valid, right? So S square is equal to 4 square plus XA square. شايفين احنا معنا XA معنا XA prime معنا XA double dot. Okay, so now what?
مش بنلاقي S prime, doctor.
Exactly, so I'm trying to find S prime. How can I find S prime from this relation?
Derive it.
Differentiate it, right? So differentiate this, right? So if you differentiate this, what do I get if I differentiate that? I know S varies, right? S is actually a function of time, مش هيك؟
2s s prime.
Exactly. So 2s s prime. Okay.
2XA. Sorry.
Same.
بيساوي velocity محل XA.
2xa XA prime مش هيك؟
Yes.
Okay. Plus what?
0.
0 ما هيك؟
زيرو لأنه ما بتغير.
Yeah, so 2 and 2 will cancel out. I can actually find S prime, okay? So what is S prime? XA prime over S, check it. Okay, what is XA?
3.
3, bravo. Multiply, what is XA prime?
4.
4. How about S?
Over 5.
Bravo. So S is equal square root of XA square, check it.
Yes.
Plus
4 squared.
4 squared. So 12 over 5 meter per second. So هلا جبنا ال SA prime. I'm sorry, the S prime اللي هي how this length is changing. مظبوط. How can I find how much basically the rate of change of this cable is actually decreasing?
S prime over VA.
How can I find the velocity of B right now?
It's the same S prime.
Why is it the same?
لأنه كيبل.
لأنه L0 is the same. مظبوط.
لا مش it's not the same but attached by the same cable. إنه
Exactly, yes. So basically, if the rate of change of this cable is equal to S prime, then this guy is decreasing by how much?
S prime.
By S prime, right? It is basically the same cable. All right. So the velocity of B, right? If I actually specify the velocity of B like that, right? Then what is SB prime? It's going to be equal to what? L0 minus SB ما هيك prime. The whole thing is derivative. مظبوط ولا لا? You guys agree?
Yes.
Okay. So if SB basically going to be equal to L0 minus S. If I'm differentiating that, I know L0 is not changing. So what is SB basically? Is going to be equal to minus S prime. Minus S prime. Okay. So if S prime is increasing, what happens to SB prime? It's going to be decreasing. Right? You don't even need to set up this equation. You can clearly see, like if you have a cable, right? And then this cable basically is varying by this velocity. And it's connected on a pulley here. So obviously this is a pulley here. Right? Then this guy basically is going to be reduced by the same amount, right? If you're pulling this cable like 2 meters, if you pull basically 2 meters of this cable on this end, basically you are pulling this cable by 2 meters. You don't really need much. But you can also consider that this length here is L0 minus S. So SB prime is a derivative of L0 minus S, right? Which is going to be, so L0 is constant, so it's going to be minus S prime. Okay. All right, guys. So now let us find the acceleration. How can I find the acceleration? Can someone help me out and then for us to get the acceleration?
If we do the derivative تبع second equation, yeah.
Bravo, derivative to our second equation, exactly. So second equation is what? Is basically S prime check equal to XA prime. Okay, so I wanna do the derivative
S
here.
prime
One more.
squared.
It's gonna be S prime squared
plus S double prime. والتاني ما زاد شيء.
Okay, is equal to X prime A squared plus XA double dot. Check. So we're trying to find S double dot. So what is S double dot? S double dot is going to be equal to X prime A squared plus XA double dot, right? Minus S prime squared divided by S. Okay, so what would then be S double dot? So S double dot is going to be equal to, what is X prime A squared? We know X prime A is going to be equal to how much? 4, right?
16.
4 squared plus XA is equal to 3. What is XA double dot?
2.
2.
Minus S prime squared. What is S prime?
12 over 5.
12 over 5, exactly. Divide that
6 over 5 في الآخر.
by 5. Okay, how much? How
6
much
over
is that?
5.
Okay, so I'm just gonna put it in meter per second squared. Okay, what is the acceleration of B in terms of that? So you can see SB prime is equal to minus S prime, right? So basically SB double dot is gonna be equal to what? Minus S double dot, okay? So the acceleration of the block is gonna be opposite of this, right? Provided that you are measuring SB like that, right? So as a point A is positive, then you're measuring the velocity of B to be negative. Why? Because let's say your sensor is here. So here my sensor is actually looking at the car or at point B, for example, right? So I'm measuring a negative velocity. It means that it is actually approaching toward me, right? Okay, so I'm sure you guys got that, right? So, so the acceleration of B is going to be equal to minus the acceleration of this guy. The acceleration of this guy is measured basically along the lens. So if this lens, if the acceleration here is positive, that means the acceleration here is going to be the opposite of this guy because it's viewed from this position or from this frame. It's coming at it. So if this velocity here is positive, you know what I mean? So if this line is actually coming toward this direction, meaning that S is actually increasing, then the velocity that I would be getting for B is going to be negative, right? Which all makes sense. All right, guys, so that is this problem. I believe we have 5 minutes left on this one. So what I'll do is let us actually try to solve this problem very quickly, and then we can continue with a new session if we have to. So let's look into example 18. Basically, we have a motor that is drawing the coordinate B with an acceleration of 2 meters per second square. So we have, this is acceleration of a point on the cable now, right? Is equal to 2 meters per second square. We know position SA basically at the bottom here is equal to how much? 1.5 meters. And then we know VB is equal to how much? 1.6 meters per second square. Okay, we need to find the velocity and acceleration of the collar at that instant. So we need to find the velocity and acceleration of this collar. So a point B on the cable basically is moving with 2 meters per second square. Acceleration about, we need to find the velocity at A. So we need to find the velocity and acceleration of the collar.
Dr. VB 1.6 or 6?
6. I'm sorry, VB is 6. So the acceleration of B is 2. Velocity at B is 6, exactly. So the velocity at B is 6. We know length SA is equal to 1.5. So how can I find the velocity and acceleration of A?
We do the same as before, L.
Exactly, me. We're going to do the same as before, right? So this guy is 2 here, and then, so basically here we have a chord, right? So let's actually call that distance to be S, check. And the distance is changing, right? As a function of time. So this guy is S of T, check it. And then, okay, so this is SA. So we're trying to find VA اللي هي شو؟ اللي هي SA prime, and then here AA is equal to what? SA double dot. And then this guy is 90 degree. How can I go about this, right? So what is S prime? What is S prime of T?
SA prime plus 2 يعني SA prime.
So S prime, rate of change of this cable is going to be equal to how much? It's going to be equal to VB, right? And then S double dot of T is going to be equal to what? Acceleration of P, right? Okay, so if you look here, basically, the rate of change of this guy is going to be, rate of change of this cable is going to be equal to rate of change of this cable, because they are wound on the same pulley. But let's just do the Pythagorean here, right? What I can do here basically is I can, based on the Pythagorean here, right? I can write that SA squared, okay, plus 2 squared is equal to how much? Is equal to S squared. You guys agree?
Yes.
Yes.
Okay, so we have SA squared plus 2 squared is going to be equal to this guy, right? And the velocity and acceleration of this cable are simply related to the velocity and acceleration at the pulley B, right? Okay, so now I'm going to have to differentiate this guy, right? If I differentiate this guy, what am I going to end up with? So 2 SA prime, derivative of 4 is obviously 0, so it's going to be 2 S prime. So 2 and 2 will cancel out, so I'm going to end up with SA prime is equal to S prime. Okay, so I'm trying to find SA prime, Sheikh. So how can I find SA prime? It's going to be equal to what? S times S prime divided by SA. Okay, so what is S in my case?
2.5.
S is going to be equal to square root of SA squared plus 2 squared, right? What is SA squared? So 1.5 squared.
1.5 square plus 2 square.
What is S prime?
6.
6. You guys all agree, you guys all should understand why SA prime is equal, or I'm sorry, why S prime is equal to 6, right? It's equals the velocity at B. How about SA now? 1.5. Okay, and that's it basically. We just found the velocity at A. Okay, guys, so our time is done here. So I'm going to close this and then I'm going to open a new session. And we can continue solving this problem and go over like a few stuff and then answer any questions that you guys may have. So I'm going to close this and then I'm going to start again.